Hello friends, this problem is related to the concept of greatest integer function, and this is a quite interesting problem. It says you have x square plus greatest integer x is equals to 3. Then what is the value of x that satisfies this equation? And it is also given that x belongs to real number set. Now to solve this problem, you must know what is a greatest integer function. So let us try to understand what is a greatest integer function. If I say y is equals to greatest integer x, this means I can have different value of x. For example, if I have x is equals to 3.2, then the greatest integer value will be 3. If I have 2.6, then greatest integer value will be 2. But if I have a negative value, minus 3.2, greatest integer will be minus 4. If we have minus 2.6, greatest integer will be minus 3. Now this can also be seen from the graph. So here I have a plot of a greatest integer function y is equals to greatest integer x. So on the vertical axis we have y and horizontal axis we have x. Now see, if x lies between 0 and 1, then y is equals to 0. This line, you see this line. And if x lies between 1 to 2, then y is equals to 1. And remember, this point 2 is not in this part. Now if you see here, if x lies between 2 and 3, the greatest integer is 2. Of course, 3 is not included here. Similarly, if x lies between 0 and minus 1, greatest integer is minus 1. Minus 1 to minus 2, greatest integer is minus 2. Minus 2 to minus 3, greatest integer is minus 3. So this is the definition of greatest integer function. Now you can write any function or basically any x value in terms of greatest integer function. So you can write any x as greatest integer x plus fractional part of x. So this x is called fractional part of x, which lies between 0 and 1. So I can say from here that greatest integer x is equals to x minus fractional part of x. Now let us substitute this into the original equation. What you have? In the original equation you have x square plus greatest integer x, that is x minus fractional part of x, and this is equals to 3. So from here I can write x square plus x minus 3 is equals to fractional part of x. Or I can say fractional part of x is equals to x square plus x minus 3. Now why I have done all this? This is because to bound x. Because I know the fractional part of x lies between 0 and 1. This means now I can say that this quantity x square plus x minus 3 lies between 0 and 1. And this will help me to find the solution of this problem. So this is the key step for this problem. Now I will break this inequality into two parts. That is, the first part is this one and the second part is this one. So let us try to see what I want to say. So I will have the first part, that is case 1. So in first case I will say I am looking for x which satisfy this condition, that is this condition. So x square plus x minus 3 should be greater than equal to 0. That is the same condition I have written here. So this is a quadratic expression basically. You can find root and then you can find what is the corresponding value after which this satisfies this condition. So now this is a quadratic equation and root of this equation will be minus b. So minus b plus minus b square minus 4ac. So this is plus 4 into 3, that is 12, and this divided by 2 times 1. So this is minus 1 plus minus root 13 by 2. So roots of this equation is minus 1 plus minus root 13. So this is from case 1. Now let us plot the sign scheme of this function. So this is my number line. Here you will have 0 and here you will have minus 1 minus root 13 divided by 2, and here you will have somewhere minus 1 plus root 13 by 2. Now see, in this expression if you put this value, this will be 0, but I am looking for greater than 0. What if x equals to 0? In this expression, what will be the value if you put x equals to 0? So this is the expression. If you put x equals to 0, then this is negative. So x equals to 0 is here. So this is negative. This means in this side you will have positive. This side you will have positive. This means this part of the scheme number line and this part of the number line basically satisfy the case 1. That is x square plus x minus 3 is greater than 0. Now consider case 2. So now case 2 we can consider, and in this case we will consider this portion of inequality. That is x square plus x minus 3 is less than 1. So x square plus x minus 3 is less than 1. This means x square plus x minus 4 is less than 0. So I am looking for x that satisfy this inequality. So this is a quadratic equation once again. So I will solve for critical value, that is for roots of this equation. So minus b, that is minus 1, plus minus b square, that is 1 square, plus 4ac, basically minus 4ac. So minus minus becomes plus. This is 16 divided by 2. So roots will be minus 1 plus minus root 17 by 2. So one root is minus 1 minus root 17 by 2, and other root is minus 1 plus root 17 by 2. So I am looking for the quantity or number that is basically less than 0. So this is less than 0. So this satisfies this inequality. So let us plot these two critical points or roots on the number line again. So what you have? So in this case you have the first number is minus 1 minus root 17. So this will be a smaller even. So this number will be minus 1 minus root 17 by 2. And this number, that will be bigger number. So this will be minus 1 plus root 17 by 2. So basically we have divided the number line into three parts. One part is from here to here, and another part is from here to here, and another part is this side. Now you are looking for this inequality, that is x square plus x minus 4 is less than equal to 0. So let us plot x equals to 0, and if you put x equals to 0, this is minus 4, this is negative. This means x equals to minus 4, this is negative. This means this side you will have positive and this side again positive. This means I need to have negative. So this means from this point onward, this satisfies this condition. This part is a possible solution. So what are the region which is in both? So this region from here to here, this is in the previous condition, and this is also satisfied by this condition. So this region satisfies both conditions. So now I can say what is the value of x that satisfies both conditions. So I can say x can be greater than minus 1 minus root 17 divided by 2, but it should be less than minus 1 minus root 13 by 2. Or what we can have? We can have x that is greater than minus 1 plus root 13 by 2, but it should be less than minus 1 plus root 17 by 2. So this is root 17 by 2. So you have two conditions. So let us consider case 1, that is when x lies between this quantity, that is x lies between minus 1 minus root 17 by 2, and this is minus 1 minus root 13 by 2. basically if you calculate this value, this will be minus 2.56 and then this is minus 2.31. So what will be the greatest integer of x? So any number that is lying between minus 2.56 to minus 2.31. So greatest integer of that is what? Minus 3. So now I can say even though x lies between this and this, but the greatest integer of x is always equals to minus 3. So this is condition 1. Now in case 2, what will happen in case 2? In case 2, your x is lying between minus 1 plus root 13 by 2 and this is less than minus 1 plus root 17 by 2. And this value is 1.31 and this value is 1.56. So x lies between 1.31 to 1.56. So what is the greatest integer? Any number that lies between 1.31 and 1.56, if you take the greatest integer of that number, then this is simply equals to 1. So greatest integer is 1. Now let us solve the original equation under these two conditions. So what was the original equation? You have original equation x square minus plus mod x and this is equals to 3. So this was the original equation. So let us solve for case A. So this will be x square. What will be the value of mod x? This is minus 3. So this is minus 3 and equal to 3. So this is x square is equals to 6. So this means x square is equals to 6. This means x is equals to plus minus root 6. So x is equals to root 6 or you can have minus root 6. Root 6 is basically 2.44 approximately. So this will be 2.44 or minus 2.44. But now see, in this case, what is the reason? The reason is x should lies between minus 2.56 to 2.31 with a negative sign. So this answer cannot be accepted. So this minus, it should be minus. So only possible solution for this case is minus 2.44, that is plus root 6, minus root 6. So in this case, we will have only one possible solution, that is minus root 6. Now let us find solution for case 2. Now in case 2, we will have x square and mod x is 1 and this is equals to 3. So this means x square is equals to 2. This means x is equals to plus minus root 2. So you have one solution equals to plus root 2. Another solution is minus root 2. Root 2 is 1.414. So this is plus 1.414 and this is minus 1.414. Now let us check whether this satisfies the original inequality or not. So in this case, x should lies between 1.31 to 1.56. This means what? We have to neglect the negative solution and we have to accept only the positive solution. So you have two solutions for this equation, that is you can have x is equals to root 2, that is 1.414, or you can have x is equals to minus root 6. So these are two possible solutions are possible for this greatest integer equation. So this was a quite interesting problem, quite challenging problem. If you miss any one of the interval, it is very easy to make mistakes. I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thanks for watching this video and I will see you in the next video with some more exciting problems. Thank you.